An electron just passed through a wall. Not around it, not over it, through it. And it happens billions of times per second inside the device you're watching this on right now. Fact number 1. Your smartphone runs on wall-phasing particles. Every single time you tap your touchscreen, unlock your phone, or stream a video, quantum tunneling is doing the heavy lifting. Inside your phone's processor are transistors. And as of 2025, the most advanced chips, like Apple's A18 Pro, pack transistors that are just 3 nanometers wide. At that scale, electrons don't travel through circuits the normal way. They quantum tunnel, meaning they literally disappear on one side of an ultra-thin barrier and reappear on the other side without ever passing through the space in between. This isn't a glitch. It's not a workaround. Engineers deliberately engineer circuits to exploit this effect. Without quantum tunneling, modern computing as we know it would be physically impossible. Your phone exists because particles break the rules of classical physics roughly 10 to the power of 18 times per second inside its chip alone. Let that sink in. Fact number 2. The sun would go cold without it. Here's something that should genuinely terrify and amaze you in equal measure. The sun's core temperature is approximately 15 million degrees Celsius. Sounds hot enough to fuse hydrogen atoms together. Right? Wrong. Classical physics says it's actually not hot enough. For 2 protons, positively charged particles that violently repel each other, to get close enough to fuse, they would need temperatures roughly 10 times higher than what the sun's core actually reaches. By the math of classical physics, our sun should be cold and dark. It should never have ignited. But it did. And it burns at a luminosity of 3.828 times 10 to the power of 26 watts. Because quantum tunneling allows protons to tunnel through the electrostatic repulsion barrier between them and fuse anyway, at temperatures that classical physics says are insufficient. Every photon of sunlight hitting your face right now exists because of quantum tunneling. Every piece of food you've ever eaten traces its energy back to this one quantum effect. Without it, Earth is a frozen rock orbiting a dead star. Fact number 3. Tunneling happens at near instantaneous speed. You might assume that tunneling, electrons vanishing and reappearing through solid barriers, must take at least some measurable time. Scientists spent decades debating this. In 2020, physicists at the University of Toronto published a landmark study in the journal Nature, using a technique called attosecond laser spectroscopy to actually time quantum tunneling in hydrogen atoms. An attosecond is 1 quintillionth of a second. That's 10 to the negative 18 seconds. Their measurements confirmed that tunneling through a barrier occurs in approximately 1.8 attoseconds. For context, light, the fastest thing in the universe, travels less than 1 nanometer in that same duration. 1 nanometer is roughly the width of 10 hydrogen atoms side by side. The tunneling process is so fast it borders on the instantaneous, which raised an explosive follow-up question. Does tunneling happen faster than light? Current consensus says no, because no usable information is transmitted. But the debate is still active in peer-reviewed physics literature as of 2024. Physicists are still arguing about this. That's how wild it is. Fact number 4. Quantum tunneling may have started life on Earth. In 2022, a research team at the University of Surrey published findings suggesting that quantum tunneling plays a direct role in DNA mutation, and therefore in the origin of genetic diversity and potentially life itself. Here's how it works. DNA is held together by hydrogen bonds between base pairs. Protons in those hydrogen bonds can quantum tunnel from one position to another. switching a DNA base from its normal form to an alternate form called a tautomer. If this tunneling happens at the exact moment DNA is being copied, it can introduce a mutation into the new strand. Most mutations are neutral or harmful, but occasionally they're beneficial, driving evolution. The researchers estimated that proton tunneling in DNA happens on a timescale of femtoseconds. That's 10 to the negative 15 seconds, making it nearly impossible for the cell's repair machinery to detect and fix. Quantum physics isn't just abstract. It may literally be why you exist as a unique human being rather than an exact copy of your ancestors. Fact number 5. A tunneling effect lets us see individual atoms. In 1981, IBM scientists Gerd Binnig and Heinrich Rohrer invented the scanning tunneling microscope, a device so revolutionary it earned them the Nobel Prize in Physics in 1986. Just 5 years later, here's the jaw-dropping part. The microscope works by holding an ultra-sharp metal tip, sometimes just 1 atom wide at its point, nanometers above a surface. It never touches the surface. Instead, electrons quantum tunnel across the vacuum gap between the tip and the surface, generating a measurable electrical current. As the tip scans across the surface, variations in that tunneling current map the exact position of individual atoms. The resolution is so precise it can image features as small as 0.1 angstroms. That's 1/10 billionth of a meter. Using this technology, scientists at IBM famously spelled out the letters IBM using 35 individual xenon atoms in 1989. The first time in human history that matter was deliberately arranged at the atomic scale. Quantum tunneling gave us the ability to write with atoms. Fact number 6. Tunneling creates a hard limit on computer chip size. Here's the cruel irony of the technology that powers your phone. The same quantum tunneling that makes modern chips work is also the force that will ultimately stop chips from getting any smaller. As transistors shrink below approximately 5 nanometers, quantum tunneling starts happening in places engineers don't want it to. Electrons begin tunneling through the gate oxide layer, the insulating barrier that's supposed to control whether a transistor is on or off, even when the transistor is supposed to be off. This is called gate leakage current, and it causes transistors to malfunction, waste energy as heat, and generate errors. Intel's own internal roadmaps, published in technical briefings through 2024, acknowledge that silicon transistors are approaching the fundamental quantum wall around the 1 to 2 nanometer range, after which classical silicon architecture may no longer be physically viable. The entire global semiconductor industry, worth $611 billion in 2023, is racing to find materials and architectures, like carbon nanotubes, graphene, and quantum dot arrays, that can work around or exploit tunneling differently. Quantum physics both built and is now threatening to break modern computing. Fact number 7. Alpha decay. Radioactivity itself is pure tunneling. Radioactive decay was one of physics' great mysteries for decades. An alpha particle, a cluster of 2 protons and 2 neutrons, sits inside a uranium nucleus, held in by the strong nuclear force. Classical physics is brutally clear. The alpha particle does not have enough energy to escape. The energy barrier around the nucleus is simply too high. It should be permanently trapped. And yet, uranium-238 nuclei do decay. They emit alpha particles. They do it with a half-life of 4.468 billion years. Almost exactly the age of the Earth. In 1928, physicist George Gamow solved the mystery using brand-new quantum mechanics. The alpha particle doesn't go over the energy barrier. It tunnels through it. The probability is extraordinarily low on any given attempt, which is why uranium-238 takes 4.5 billion years to halve its population. But with an incomprehensible number of atoms in any sample, tunneling events happen constantly. Every smoke detector that uses americium-241, every nuclear power plant, every medical imaging isotope, all of it traces back to Gamow's 1928 realization that radioactive decay is nothing more than quantum tunneling on a nuclear scale. Fact number 8. Scientists have tunneled entire molecules. And the record is stunning. For most of quantum mechanics history, tunneling was considered a phenomenon limited to tiny, low-mass particles, electrons and protons. The heavier the particle, the less probable the tunnel. But in 2019, a team at the University of Göttingen in Germany demonstrated quantum tunneling of an entire organic molecule, a cyclopentadienyladine carbene, a compound containing multiple carbon and hydrogen atoms, tunneling between two structural forms at temperatures as low as 11 Kelvin, roughly -262 degrees Celsius. The molecule's total mass was 12 atomic mass units of carbon involved in the tunneling motion, orders of magnitude heavier than a lone electron. More shockingly, in 2022, researchers studying hydrogen-rich compounds found evidence of proton tunneling driving chemical reactions at temperatures approaching absolute zero, conditions where classical chemistry should be completely frozen and inert. This obliterates one of science's long-held assumptions about what can and cannot tunnel. Scientists now believe tunneling chemistry, reactions driven entirely by quantum tunneling rather than heat, may be occurring in the frozen clouds of interstellar space right now, producing complex organic molecules that could seed life on other planets. The universe is quietly tunneling its way toward complexity, with or without our permission. And there you have it. 8 facts about quantum tunneling that prove the universe is far stranger, more violent, and more beautiful than anything classical physics ever imagined. Particles vanish through walls. The sun burns against all odds. Your DNA mutates in femtoseconds. And the entire digital world you live in is balanced on the razor's edge of a quantum effect that could collapse modern computing within a decade. Subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.